Hello, my name is Mitch Savali, and this is my Physics 2211 Lab 1, which is charge tape. In this lab, we will be going through an introduction, analyzing some experimental results, going through a computational model, and asking some what-if questions. In this lab, we will conduct an experiment involving the interactions between two positively charged tapes, one suspended and one dynamic. From this, a computational model will be constructed, and the fundamental physical principles interpreted in this lab is important because it displays a real-world example of equilibrium, electric fields, and the interaction between charged everyday materials. From this lab, the electric and gravitational force acting on a suspended tape around 0.00199 newtons, the charge of an individual tape around 2.3 times 10 to the negative 8 coulombs, and the number of electrons per tape around 1.42 times 10 to the negative 11th, and the ratio of electrons lost per atom on the tape would be around 3.5 e to the negative 7 can and will be found. Some fundamental principles and equations necessary for this lab include Coulomb's law, gravitational force, the equation for electric field, a derived charge formula, static equilibrium, and Newton's second law, all allowing us to set F electric plus Fg equal to 0 and some polarization of neutral materials. In our pre-lab experimentation, it was found that the U tapes were positively charged as they were attracted to negatively charged plastic pens. This implied a loss of electrons and allowed us to continue the lab setup as it follows, with suspended one slack piece of tape of charged tape, and which is charge tape B, which is our system, and then another tape A, which is charged tape, is brought from below towards the charged tape B, and then at the distance at which B starts to float or be repulsed from tape A is measured as our separation distance. The experiment results are shown here. In the picture, you can see what happens is that when tape A is brought towards tape B, the repulsive force of tape A was found to be 0.00220 kilograms. The length of the tape is about 0.2 meters, and the width of the tape around 0.02 meters. This allowed us to find the area of the tape, which we use in later calculations. The force of gravity was found using negative mg, and using this, and knowing that the force of gravity equals the negative of the force of electricity, we found that Fe equals 0.00199 newtons, and the separation was distance measured to be 0.0482 meters. And from this, the charge on B, the system, was found to be 2.3 e to the negative 8 coulombs. An area of an atom was given 1 times 10 to the negative 20th, and using this, we could find the number of atoms per tape, or on the tape, which is 4.06 times 10 to the 17th. Using this, we can find the number of deficit electrons, and this was the charge over the number of electrons. And lastly, the ratio of electrons transferred from the tape atoms, which is around 3.5 times 10 to the negative 7. This here now is a computational model that I constructed. Using Python first, I identified the constants and SI units, and then I created the particles themselves. I used the radius of 1 just so they can be seen. I had the scale of the separation distance by 100 so that the individual particles that represent tapes A and B could be seen. Then I created the forces acting on the system. I set Fg equal to the vector 0, negative tape mass 1 of the constants times g, and then I made a print statement for the magnitude of Fg, and I did the same with Fe, except for this time it was the negative of the force of gravity based on the static equilibrium we talked about. Next, I calculated the charge using that equation that was derived from earlier and printed the charge in coulombs. And lastly, I created a visualization with a scale of 1750 of the arrows representing the electric force on the tape system B by A, which is the red, and the force of gravity on B. Some what-if questions that I decided to go into. What if the electrons had a positive charge and the protons had a negative charge? What would this change about the observations we made with the tapes and the other charged objects? The only observation that would likely change would be the interactions in the pre-lab with that negatively charged pen. If the signs were flipped, the magnitudes would remain the same, and the repulsion, that force between the two, would also be the same. The same fundamental principles could and would be applied to complete the calculations and experiment just as before. Why is it important to handle the charge tapes with as little as possible? What happens when the charge tape comes into contact with your hands or other objects due to the electron deficit? They have a tendency to pick up electrons that they're handled, returning them to a more neutral state to remain as charged as they are. They must be handled as little as possible, and preferably be used as quickly as they are ripped off the base tape, and even the contact in the air can actually change the current state. Lastly, some errors and solutions I experienced during this lab. A few possible errors in this lab include the lack of consistent length of tape, as well as the handling of the tape needed to be slightly shorter so it could actually be lifted under the books, and tape be longer so it could hang slack along. The handling of the tape made the separation distance smaller than it could have been under correct conditions. A fix for this could be creating a neutrally charged two-prong tape holder can connect the tape and edges with as little surface area left between the books. Thank you for watching.